So, my dear students, today's topic is reaction of ammonia derivatives with carbonyl compounds, that is aldehydes and ketones. Now, listen. If you consider, don't write it, okay? If you consider ammonia, nitrogen has lone pair of electrons, that's why ammonia acts as nucleophile. When one hydrogen atom of ammonia is replaced by certain groups, then the compounds are called ammonia derivatives. All the ammonia derivatives can act as nucleophile because nitrogen has lone pair of electrons. Instead of G, if we write OH, the compound is called hydroxylamine. Keep NH2 as it is. Instead of G, if we write NH2, that's called hydrazine. Now, third derivative is phenylhydrazine. Just replace one hydrogen by benzene, that's called phenylhydrazine. If we mark the number of carbon atoms, so this is 2 position, this is 4 position. If you insert nitro group at 2 and 4 positions, such as the fourth one is 2,4-dinitrophenylhydrazine. Insert nitro group at 2 and 4 position, you get. And the fifth one is called semi-carbazide. How do you remember semi-carbazide? You know that carboxylic acid has formula. This is carboxylic acid group. If you replace the OH group by NH2, it's called amide. See, if you compare phenylhydrazine and semi-carbazide, what is the difference? In phenylhydrazine, there is one benzene, and instead of benzene, if you write amide group, CONH2, it's called semi-carbazide. These are the reagents. During a reaction, reagents should be taken in a small amount. Each reagent reacts with 2 reactants, acetaldehyde and acetone. Remember it, the reaction of aldehydes and ketones with ammonia derivatives takes place in weakly acidic medium. What is the technique? Listen the technique. Remember it, there are 10 reactions, 5 ammonia derivatives, these are, and 2 carbonyl compounds, aldehyde and ketone. Say we take acetaldehyde and acetone. It is not that the reaction takes place in acetaldehyde acetone. The reactant also occurs with benzaldehyde also, remember it. But if there is bulky group, no reaction occurs. This is called steric hindrance, that you know. So 5 ammonia derivatives, 2 reactants, acetaldehyde and acetone. So altogether there are 5 into 2, that is 10 reactions. Hardly I will do 4 reactions, 4 to 6. Rest are your homework. You will do it, okay? Just follow the technique. Follow the technique. You see, in every ammonia derivative, there is NH2 at the left hand side. See it. NH2, 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 everyone. The technique is just shift the hydrogen of front NH2. Just shift before. Others remain as it is. Just shift. This is the technique. Whenever you want to write the 10 reactions, just shift the hydrogen in front of nitrogen. The rest don't touch, write as it is. So let's start the reaction. 5 to the 10 reaction. Please do understand. I will write hardly 2 or 4 reactions. You will do rest. Okay. Now reaction with hydroxyl amine. Number A. So listen, whenever you write the reactions with aldehydes or ketones, replace the hydrogen by CH3 group, you get ketone. Generally, we used to draw aldehyde or ketone like this way. But whenever you write the 10 reactions, write C double bonded O as it is. Write C double bonded O like this, not as it is, like this. Straight. I have already told you that whenever you practice at home the reactions of carbonyl compounds, aldehydes, ketones with ammonia derivatives, just bring the hydrogen of left side in front of nitrogen. The latter don't touch. I have written this way to show that water is eliminated. Now what you see, write as it is without changing anything. Say product these are the product. How to write the name of the product? It's the addition product. So write down this is functional group NOOH, double bond NOH. This functional group is called oxime, OXI. Aldehyde functional group, formula C double bonded OH. Ketone is also functional group C double bonded O. Carboxylic acid also functional group C double bonded OH. Similarly, double bond NOH called oxime. This compound is formed from acetaldehyde. So the product is, just remove dehyde and write oxime. OXIME, oxime. So it is called acetaldoxime. See, just remove EHYD, acetaldehyde, by oxime, acetaldoxime. So it is called acetone, just remove B, write oxime, acetone oxime. So the next with 2,4-dinitrophenylhydrazine. Rest you will do, okay, with 2,4-dinitrophenylhydrazine. Follow the technique. Draw one benzene ring. Mark the carbon atoms. Reference to this is 1, 2, 3, 4, 5, 6. At the 2 position and at the 4 position, write 2 nitro groups. So this is the reactant. Reagent. It reacts with acetaldehyde and acetone. The technique follow. Just write the C double bonded O straight. How to write it? I have already given the technique. Just bring this hydrogen in front, not others. The reaction takes place in weakly acidic medium. In every cases, byproduct is water. In every cases, byproduct is water. This is addition product. Write the name of all. So the product name is acetaldehyde because it comes from acetaldehyde. 2,4-dinitro. Stop writing, listen now. This is hydrazine. I have not written here gene. The technique is change gene to zone. So instead of gene, write zone. Gene zone, remember it. Z-O-N-E zone. Understand? Gene changes to zone. Now with anyone? Acetone. Very good. So with very easy to write acetone. Just instead of hydrogen, write CH3. So here instead of hydrogen, write CH3. So the product name is acetone 2,4-dinitrophenylhydrazine. So one thing, remember it, this is very important for entrance. When acetaldehyde or acetone reacts with 2,4-dinitrophenylhydrazine, and orange red colored precipitate is formed. Orange red colored precipitate is formed. This is known as DNP test. Remember it, during any reaction, if there is change of color, if any precipitation takes place, if product has characteristic smell, these are the identification test. So, reaction of 2,4-dinitrophenylhydrazine with aldehydes and ketones also identification test, because the product which we get is a precipitate orange red colored substance. In the previous reaction, that is with acetaldehyde, I have written the product acetaldehyde 2,4-dinitro, that is also orange red. Write down, instead of acetaldehyde is write orange red PPD. Okay, in the previous reaction also write orange red. So the reaction of 2,4-dinitrophenylhydrazine with acetaldehyde or acetone is called DNP test, and this is the identification test of aldehydes and ketones. No other compounds, carboxylic acid, alcohols, no other compound responds to this test. Remember it. So let's write the notes. Important for entrance also, okay? Write a note, everyone. So the reaction of 2,4-dinitrophenylhydrazine with aldehydes and ketones is called DNP test. This is an identification test of aldehydes and ketones, as we get orange red PPT. No other compound give response to this test. So remember it. Reaction with 2,4-dinitrophenylhydrazine and carbonyl compounds are the identification test of aldehydes and ketones. Clear? Carboxylic acid also contains C double bonded O group, but carboxylic acid does not give test. Remember it, carboxylic acids does not give any test of aldehydes or ketones, though it has C double bonded O group. Okay. Now the last two I will do reaction with semi-carbazide. Reaction with semi-carbazide. Rest you will do it. Okay. So This is semicarbazide. It once reacts with acetaldehyde and then acetone. Okay. Write C double bonded O straight away here. Just bring the hydrogen of left NH2 group in front of nitrogen. That's the technique. Rest, don't touch. The reaction occurs in weakly acidic medium. Water is eliminated here. What you see, write as it is. So the name of this compound is this is the technique. Write JEE to zone. JEE to zone in the product name. So this is addition product with acetaldehyde. So write at first the name of acetaldehyde. Instead of JEE, write zone. Remember, this is the technique. So the last with acetone, okay, with acetone. Just change the hydrogen by CH3 group. Write in another reaction, okay, don't overwrite, another reaction. Separate reaction rightly, don't overwrite it. Just follow my technique, how to remember it. So the name of product is acetone semicarbazone. So these are the reactions of ammonia derivatives, okay. Now, only two questions. This is semicarbazide. It has two NH2 group. One at end. But the reaction of carbonyl compounds with semicarbazide, only one NH2 group participates. Why? Once again listen the question, this is NCERT question. Semicarbazide contains two NH2 group. But why only one NH2 group participates in nucleophilic addition reaction with aldehydes and ketones? Can you do? Listen. So the question is, I think it down to this question will come, okay? And in entrance also the reason is asked. You see there are two amino group in semi-carbazide. Only this NH2 will participate the reaction. But this NH2 group which is attached to carbonyl group is not participated. Why? You know that these are all examples of nucleophilic addition reactions, and all the ammonia derivatives acts as nucleophile because the left side NH2 group contains lone pair of electrons. So this NH2 group adjacent to C double bonded O participates in resonance. Thus, there is no lone pair of electron on nitrogen atom. So this NH2 group cannot act as nucleophile. Because there is no lone pair of electrons, so it cannot act as nucleophile. That's why, though there are two NH2 group in semi-carbazide, only one NH2 group participates in reaction. Write its name also, okay? Semi So how to write the answer? At first draw this resonance structure. Draw this resonance symbol, okay, not that, symbol is. Draw the resonance structure and then write remember, this type of question carries only 1 marks, okay? So don't write too much. The explanation is important for entrance. The question is important for board. What is the explanation? Reason. The lone pair on nitrogen atom due to resonance is not available because it has positive charge. That's why this NH2 group does not participate in reaction, because you know that the reactions are example of nucleophilic addition reactions. All the ammonia derivatives should act as nucleophile. Here I think, so the last question, okay. Write it, huh? Now, this is the last question. I think this question may come in term 2. The explanation is entrance question. Carboxylic acid contains keto group or carbonyl group, but carboxylic acids do not show any reactions of carbonyl compounds, that is aldehydes and ketones. Why? Once again listen. Though carboxylic acid contains C double bonded O group, but carboxylic acids do not give any reactions of aldehydes and ketones. Why? Last, okay, please do remain. This is carboxylic acid, general formula. Oxygen has lone pair of electrons. You know that the atomic number of oxygen is 8, configuration 2,6. So valence shell of oxygen contains 6 electrons. 1, 2, 3, 4, 5, 6. 2 participates in bonding and rest. These are lone pair. The non-bonding electrons called lone pair of electrons. As the oxygen atom is more electronegative and oxygen is attached with carbon by pi bond, so oxygen has a tendency to attract the pi electron from carbon. As oxygen attracts the pi electron from carbon, so there is shortage of electron on carbon atom. That's why the lone pair on oxygen atom shifts here. This is a symbol of resonance. In my another class, okay, after some days, I will publish one lecture on resonance and hyperconjugation, okay. So please do remain with me. So listen, due to resonance, the carbon has no positive charge. Due to the absence of any positive charge on this carbon atom, carboxylic acids do not show any reaction of aldehydes and ketones. Draw it, okay, at first. This is the reason, okay? This is the reason, because now right up to this, okay? For you, listen, I repeat. This is keto group or carbonyl group, present is aldehyde and ketone. Due to resonance, the carbon becomes positive charge. In previous classes, I have already discussed. So the nucleophile easily gets attached to the positively charged carbon and we get the product. This type of reactions are called nucleophilic addition reactions. So the main funda of nucleophilic addition reaction is that development of positive charge on this carbon atom. But here, due to resonance in carboxylic acid, no positive charge is developed on this carbon atom. That's why carboxylic acids, though contains C double bonded O, never gives any chemical reactions of aldehydes and ketones. Okay, so my dear students, this is direct classroom format coaching, and always I used to publish without any edition. So these are no edit lecture. Maybe sometimes some noises are there, please do ignore it. I have so many plants inside my center. You know that I like indoor, outdoor, both the plants. That's why sometimes birds may come inside the classroom. So sometimes you may hear the sounds of birds. So please ignore the extra noise. Okay. Thank you for being with me. So please watch my next videos, and in my next video I will deliver a lecture of preparations of aldehydes and ketone. So please do subscribe my channel so that I will reach to you as soon as possible. Okay, and please watch my all the videos. In every video I share my 27 years knowledge with you. Okay, so if my teachings will be helpful to you, I will be ever remain grateful. Thank you for being with me. Okay.